Hello there, and welcome to ASMR Galaxy. My name is Jackson Galaxy, and today's video will be audio only, ADHD relief for sleep and focus. Today I will be reading boring and dry Wikipedia articles, just so that you may have some noise in the background for your other tasks, or even to help you fall asleep. This video will be audio only simply because we had an emergency with one of our pets. One of my kitties was attacked and had to go through surgery, so I'm looking after her. Any donations and things on the Patreon page for the next little while are simply going to help pay for her surgery and that kind of thing. So if you'd like to help us get through this sort of difficult time, please consider doing so, but don't feel obligated by any means. By design, this video is meant to be a little boring and something to be ignored, just noise in the background. As this is a video meant to help you fall asleep or relax or focus, I'll request all of the YouTube things up front, so please subscribe to the channel if you'd like to see more of these types of videos. Please like the video if you do indeed like it, and check out the description for our other channels, including our Patreon page, where if you'd like to help us fund these videos, you can do that there. Thank you for your consideration. Now, on to the video. This Wikipedia article will be on wooden dowels. It can be found at wikipedia.org/wiki/dowel. A dowel is a cylindrical rod, usually made from wood, plastic, or metal. In its original manufactured form, a dowel is called a dowel rod. Dowel rods are often cut into short lengths called dowel pins. Dowels are commonly used as structural reinforcements in cabinet making and in numerous other applications, including furniture shelf supports, movable game pieces in the form of pegs, hangers for such items as clothing, keyrings, and other tools, wheel axles in toys, detents in gymnastic grips, or supports for tiered wedding cakes. Wooden dowel manufacturing process. The traditional tool for making dowels is a dowel plate, an iron or hardened tool steel plate with a hole having the size of the desired dowel. To make a dowel, a piece of wood is split or whittled to a size slightly bigger than desired, then driven through the hole in the dowel plate. The sharp edges of the hole will shear off the excess wood. A second approach to cutting dowels is to rotate a piece of oversized stock past a fixed blade, or alternatively to rotate a blade around the stock. Machines based on this principle emerged in the 19th century. Frequently, these are small, bench-mounted tools. For modest manufacturing volumes, wood dowels are typically manufactured on industrial dowel machines based on the same principles as the rotary cutters described above. Such machines may employ interchangeable cutting heads of varying diameters, thus enabling the machines to be quickly changed to manufacture different dowel diameters. Typically, the mechanism is open-ended, with material guides at the machine's entry and exit to enable fabrication of continuous dowel rods of unlimited length. Since the 19th century, some of these dowel machines have had power feed mechanisms to move the stock past the cutting mechanism. High-volume dowel manufacturing is done on a wood shaper, which simultaneously forms multiple dowels from a single piece of rectangular stock. These machines employ two wide rotating cutting heads, one above the stock and one below it. The heads have nearly identical cutting profiles, so that each will form an array of adjoined side-by-side half-dowels. The heads are aligned to each other, and one head is shaped to make deeper cuts along the dowel edges so as to part the stock into individual dowel rods, resulting in a group of dowel rods emerging in parallel at the machine's output. Applications. The wooden dowel rod used in woodworking applications is commonly cut into dowel pins, which is used to reinforce joints, support shelves, and other components in cabinet making. Some woodworkers make their own dowel pins, while others purchase dowel pins pre-cut to the required length and diameter. When dowels are glued into blind holes, a very common case in dowel-based joinery, there must be a path for air and excess glue to escape when the dowel is pressed into place. If no provision is made to relieve hydraulic pressure of air and glue, hammering a dowel home or clamping the joint can split the wood. An old solution to this problem is to plane a flat on the side of the dowel. Some sources suggest planing the flat on the rough stock before the final shaping of the round dowel. Some dowel plates solve the problem by cutting a groove into the side of the dowel as it is forced through. This is done by a groove screw, a pointed screw, intruding from the side into the dowel. Some dowel pins are fluted with multiple parallel grooves along their length to serve the same purpose. When two pieces of wood are to be joined by dowels embedded in blind holes, there are numerous methods for aligning the holes. For example, pieces of shot may be placed between the wood pieces to produce indentations when the pieces are clamped together. After the clamp is released, the indentations indicate the center points for drilling. Dowel centers are simple and inexpensive tools for aligning opposing blind holes. Various commercial systems, such as Dowelmax, have been devised to solve this problem. Alternative joinery methods may be used in place of conventional dowel pins, such as Miller dowels, biscuit joiners, spline joints, and proprietary tools such as the domino jointer. History. The word dowel was used in Middle English. It appears in Wycliffe's Bible translation, circa 1382, in a list of the parts of a wheel. Quote, "and the spocus and dowlus of the wheelus," end quote. Cognates with other Germanic languages suggest that the word is much older, as in duvel in Dutch or dubel in German. Wooden dowels have been used in manufacturing and woodworking for many centuries. One of the earliest documented cases of wooden dowels is in Japanese shrines in AD 690. They were constructed using only wood, wooden dowels and pegs, and interlocking joints. Around AD 1000, Leif Erikson sailed across the North Atlantic in a ship that was largely constructed of overlapping planks held together by wooden dowels and iron nails. The wooden dowels did not rust, and thus were more reliable than iron for long expeditions. Metal dowels. In machinery, metal dowels or dowel pins are often used as precise locating devices in machinery. Steel dowel pins are machined to tight tolerances, as are the corresponding holes, which are typically reamed. A dowel pin may have a smaller diameter than its hole so that it freely slips in, or a larger diameter so that it must be pressed into its hole. This is called an interference fit. When designing mechanical components, mechanical engineers typically use dowel holes as reference points to control positioning variations and attain repeatable assembly quality. If no dowels are used for alignment, example, components are mated to bolts only, there can be significant variation or play in component alignment. Typical drilling and milling operations, as well as manufacturing practices for bolt threads, introduce mechanical play proportional to the size of the fasteners. For example, bolts up to 10 millimeters in diameter typically have play on the order of 0.2 millimeters. When dowels are used in addition to bolts, however, the tighter dimensional tolerances of dowels and their mating holes, typically 0.01 millimeters, result in significantly less play on the order of 0.02 millimeters. Manufacturing costs are inversely proportional to mechanical tolerances, and as a result, engineers must balance the need for mechanical precision against the cost, as well as other factors such as manufacturability and serviceability. There are a variety of specifications, military, ISO, DIN, ASME, that pins may be made to, and size can even vary by dowel pin material. Metric dowel pins are often found in two sizes. In DIN 6325 standard, the dowel pins are slightly larger than the nominal value. For example, a 3 mm dowel pin will range from 3.002 to 3.008 millimeters. In the ISO 2338 standard, the dowel pins are slightly smaller. 3 mm nominal range is 2.986 to 3.0 millimeters. The terminology, for example, oversized or standard, is not entirely consistent across multiple suppliers. In inch, pins oversized refers to pins that are more significantly oversized for worn-out dowel pinholes. The most common inch-size pins are slightly oversized, and undersized versions are also available. In automobiles, dowels are used when precise mating alignment is required, such as in differential gear casings, engines, and transmissions. Bolts in a bolted joint often have more important function as a dowel, resisting shear forces. For this reason, many bolts have a plain unthreaded section to their shank. This gives a closer fit to the hole and also avoids some problems with fretting wear when a screw thread bears against an unthreaded component. In woodworking, a cross dowel is a cylindrically shaped metal nut, for example, a metal dowel, that is used to join two pieces of wood. Like other metal nuts, it has an inside threaded hole, although the hole is unusual in that it passes through the sides of the dowel. One or both ends of the dowel are slotted, with the slots oriented parallel to the threaded hole through which the bolt will pass. In a cross dowel application, the two pieces of wood are aligned and a bolt hole is drilled through one piece of wood and into the other. A dowel hole is drilled laterally across bolt hole and the cross dowel is inserted into it. A screwdriver is inserted into the slot at the end of the cross dowel, and the dowel is rotated so that its threaded hole aligns with the bolt hole. The bolt is then inserted into the bolt hole and screwed into the cross dowel until the wood pieces are held tightly together. This Wikipedia page contains 10 references and was last edited on the 13th of April, 2021. Thank you for listening.